So I had the audio download. Try it again. Can you do it again?
Yeah. We're just going to wait for a few minutes for people to trickle in, and then we'll be starting momentarily. So wait 20 seconds. Wait. All right. Welcome, everyone, to the 2020 ARVP Annual General Meeting. Today, we're going to go over some aspects about our team. You can learn more about what we do, what sub-teams there are, and how to join. Before we get started, if you have any questions, feel free to type them in the chat. We'll be keeping track of them, and we'll answer all the questions at the end. So, hi, I'm Jenny. I am in my 4th year of engineering, and I'm this year's project co-lead.
Hey guys, I'm Nicholas. I'm also project co-lead this year, and I'm in my 4th year.
So on this slide here, you can see our executive team and all the team leads that go along with our respective sub-teams. You'll get to meet them in just a few moments. So our mission statement is to promote, develop, and apply the use of robotic systems to current and future generation. We're building Alberta's autonomous future. We're probably the only club on campus that does anything autonomous.
So here's some past generations of some land-based robots that ARVP's made. This is because ARVP has been around for quite a while. We started with autonomous vehicles on land, and then we moved to underwater for greater challenges. So here's some more past generations, land-based, and you can see on the right, one of our robots, Ursa Minor, actually ran for the Student Union president. We actually have some banners left over in our club's room from that event. Here's some of our older underwater robots. And in the middle is our TIE fighter robot called Ori, which was in use from 2017 to 2019. We won 4th out of 56 international teams in 2019. This year, we're developing Arctos, which has stereo vision and an arm for manipulation tasks.
So the competition, what do we really do? What are we building this robot for? So every year we take our robot to a competition called RoboSub. It's usually held in San Diego, but this year, because of the pandemic, it was held online. Hopefully next year it'll be back in person again, but we're not too sure. It's sponsored by the US Naval Research and some other big sponsors. It's usually held in a naval base. The competition consists of movement control, vision and environmental awareness, and object manipulation. So you can see the Transect Center where the competition is held. It is a naval base, I believe. And the competition in the pool is held in a section of the pool where you start from the launch platform and then you can end at the surface octagon. In between, there are different tasks you can do, such as hitting buoys, shooting torpedoes, some object manipulation, or like going through a gate, like vision detections.
The robot, what do we build? Since Arctos is still under construction, let's go through some things about the last year's robot, Ori. This is our competition video from 2017.
The Autonomous Robotic Vehicle Project has grown a lot in the last year. We created a business team from the ground up to compete with some of the best universities from around the world. As one of the leading engineering schools in Canada, along as with world-renowned research into artificial intelligence, the University of Alberta is one of the ideal locations for our newest creation, Ori. With support of friends and family and the Edmonton business community, including Petro Barrier Systems, DC Solutions, and Cavalry Fence Incorporated, we have raised over $35,000 for this year's competition. At ARVP, we have one goal: to haul ass.
It's the one and only Digo Double G.
Oh, hey, just finished machining the new hull for ARVP's robot this year. We went with the double hull construction. This is gonna let us access those electronics boards a lot easier. It's really gonna be useful during the heat of the competition, as it's gonna be a lot more efficient. So this is you. And this is the guy she told you not to worry about. This year's design has side skirts, is more compact, and is able to do complex maneuvers, including barrel rolls.
The electrical system acts as the neural network for Ori. With advanced power systems and robust circuit design, Ori is more versatile and stronger than ever. One of the main goals for the electrical team this year is to make everything fit inside an 8-inch tube. Diving into the power systems, pun intended, we use 3 DC-DC buck converters, all fitting on a really small board, making it all fit into Ori without degrading anything on performance.
The computer system is the brain of Ori. This year we've completely redesigned our software system in order to make it modular. This means that we can expand our programming to include more advanced algorithms in the future. In previous years, we had to go to the pool to test all of our code. Now, with the new simulator, we're able to test all of our code on the computer. Well, if you'll excuse me, I need to get coding.
There's nothing to add. There is no life I know to compare with your imagination. Living there, you'll be free if you truly wish to
Okay, so Ori 2.0's specifications. This slide shows the weight, depth, dimensions, degrees of freedom, number of thrusters, and battery life of the robot you just saw. So our 2019 competition results, I'd just like to highlight again that we won 4th place in 2019 out of a ton of international teams. It was a great win. So here is a video of Ori at RoboSub in 2017 in the Transdeck Pool in San Diego, going through the obstacle course. So here we have the team at RoboSub 2018. You can see we're holding a big check with some money we won. And yeah, so every year we go to San Diego, and it's a lot of fun. We end up going to a big aircraft carrier museum, and the San Diego Zoo is also there as a really fun time. In terms of development, we're completely student designed and assembled. We have 3 core design teams: mechanical, electrical, and software. But supporting all of this, and we really couldn't do it without their help, is the admin team.
Hello, my name is Andrew Del Ciopo. I'm a 4th-year mechanical engineering co-op student, and I'm one of the mechanical team leads for 2020-2021.
And I'm Jared, the other mechanical co-lead. I'm in my 3rd year of mechanical engineering.
Right now, we have an existing robot Ori that we used in competition from 2017 to 2019. We're currently in the process of creating a new robot to compete next year, Arctos. This robot is currently being assembled and improved.
the mechanical team is responsible for the design of the physical components of our robot. So this includes everything from the main structural body of the robot to the auxiliary systems, such as the torpedoes and the mechanical claw. We also are responsible for maintaining and modifying the robot to meet any existing needs or changing needs. And we also do continuous improvement to deliver best competition results possible.
This year, our main task is getting Arctos ready to compete for next summer. We have new systems to design and existing systems to improve on. We also put our robot through an extensive testing process to iron out the flaws. Additionally, we'll be starting design on the next generation robot after Arctos later on this year.
As part of the mechanical team, you'll learn quite a few things. The main thing is SolidWorks, which is our CAD program that we use to design all our components for the robot. And then we also use the PDM, which is our version control software, which is pretty much Google Drive for SolidWorks. And then you also learn manufacturing processes such as laser cutting, 3D printing. We use 3D printing a lot to do rapid prototyping. So you'll get used to all these methods of manufacturing, and you'll learn all of them. You also learn the mechanical design process and a lot. We go through that a lot, and then there's a possibility of learning some computation fluid dynamics and finite element analysis, which is something we're trying to introduce to our design process.
The ARVP mechanical team follows a similar design process to a small robotics company. We conduct background research to come up with ideas and initial design concepts. We then refine these concepts and make some solid models of them. We then do a design review process and analyze these designs to find flaws, and then, if necessary, go back and remodel. Then we create drawings and get our parts and subassemblies manufactured, and then we put the robot through an extensive testing process of continuous improvement, where we slowly, incrementally improve Arctos and get it ready for competition.
Hey everyone, I'm Kirill Makachev. I'm an electrical engineering alumnus, and I will be the electrical lead for the upcoming year. The main tasks for the electrical team are designing and building printed circuit boards, managing power and communication wiring, which is basically wiring systems and troubleshooting issues during testing, and to develop and maintain code for microcontrollers, which is known as firmware programming. Here's some of the projects that we have planned for the upcoming year. We'll be developing driver circuitry for the mechanical arm, which was just shown by the mechanical team. We're in the process of designing an underwater acoustic modem, which is a device that will be used for inter-robot communication. We don't have a second robot, but demonstrating a viable solution is worth a lot of points in the competition. We will be updating and redesigning some of the existing boards and firmware. Last year we designed some boards, but around the time the parts came in, COVID hit and we didn't get a chance to assemble them. We're currently working with the faculty to gain access to the engineering buildings so we can build them for the new robot. Finally, we are working on improving documentation for all electrical aspects of the robot so that new members in the future have an easier time catching up and contributing meaningfully to the group. The skills you'll learn are embedded system design, PCB development and assembly, firmware programming, and soldering. The tools you use are Eagle, which is used for PCB design, LT Spice, which is used to test the functionality of your circuit, and GitHub for saving progress. The PCB design process, which is mainly what you'll be doing as part of the electrical team, it starts with you researching and finding the components that will be needed to implement your board's goals. You will then design a schematic, which is basically a representative wiring of your board. Then you perform simulations to ensure that components in the schematic are wired correctly. Once the simulations run as desired, you will design a board layout, which is how the PCB will look when the assembly is actually completed. We then order the board and the components that go on it, and once those are received, you will assemble the board mainly through soldering. And finally, we verify that the board works as designed.
Hi,
I'm Justin, and I'm a fourth year computing science and statistics double major, and I will be co-leading the software team this year.
Hey, I'm Megnath. I'm an electrical engineering alumnus, and I'm also the software co-lead for this year.
So software is the glue that connects the high-level programming with the low-level hardware. It is the brain of the whole system. Here you can see Ori ramming a target underwater. A lot is involved in this seemingly simple task. Software can be broken into three major groups. Perception involves understanding the world around you and using a variety of different sensors and mapping tools. Planning involves a mission plan and making sure the robot transitions from task to task. Lastly is controls, which involves figuring out where you are and where you want to go. Our software stack encompasses many facets of computer science. This mind map attempts to touch on every aspect of the team. No matter what kind of classes you're taking that involve software, there's something you can expand on it in ARVP. We currently have had a lot of success using the YOLO to detect objects quickly and efficiently underwater. We are working on transitioning to YOLACT image segmentation, which will highlight the pixels of the object we're interested in. We train our neural networks using AWS on the cloud, which is the easy part. The harder part is integrating those neural networks with our software stack and running them quickly and efficiently. A key part of vision and mapping is translating our 2D vision into a 3D map estimate. This estimate can be understood by the robot. Understanding where objects are in space is needed to move around them and manipulate them. We're also currently experimenting with using a 3D camera to create a better map estimate. Our mission planner is key for the robot to understand what tasks it wants to perform. A mission can be split into multiple tasks, which can further be split into multiple states. The robot will transition between these states. It's important that the robot can detect when it has completed or fielded a task, so that it can move on to a new task. Our simulator is crucial when we are developing code for the robot. It allows us to test our missions as if we actually had the robot in the water. It's important that we test new missions in the simulator first to prevent damaging our robot in the real world. We are currently working on using more realistic physics, which will allow the robot to interact and collide with the simulated environment. So now it can collide with walls rather than just go right through them. And I'll pass it off to Megnath.
Thank you, Justin. So one of our mapping tasks in the competition is to locate an acoustic pinger that is in the pool. So we started to tackle that task by adding a sonar module to our robot. And software's role in that is to try to estimate where the position of that pinger is in the pool. There is a lot of interesting mathematical methods that were used to locate the pinger. And if you ever get a chance to work on this project, you would be expanding on a system like this. So there'd be a lot of opportunity to learn about the mathematical methods in this system. Next slide. An important part of any robot is its ability to locate itself and be sure of its position, rotation, and state in the pool. This is called localization, and the robot localizes itself and it retrieves an entity called pose, which basically gives it all this information. We do this in our software stack by fusing data from various positional sensors like IMU, DVL, and we bring them together using a technique called Kalman filtering. We have a lot of opportunities to work on this aspect, and you would get to learn a lot about control systems and sensor fusion in this system. Next slide. So now we know the map of the robot, map of the environment, and we now know the position of the robot in that environment. Now the robot needs to tackle its tasks, and that's where our control architecture comes in. Our control architecture uses the motion planner and the map to create velocity targets, targets that of the state that the robot needs to be in. And these targets are fed into our LQR controller. And that would be explained in our next slide. The LQR controller uses the data of the targets that the robot has determined, and it uses a set of tuned parameters using Jacobian matrices according to control theory, and it uses it to control different actuators and move the robot in all different axes. So we currently support forwards, backwards, roll, pitch, yaw in all different axes for a robot, and as you can see in the video in the slide. Next slide. So as you can see, we build a lot of systems, but we try to keep our software workflow the same as any other software company in the world. So we bring in continuous integration to bring all our systems together using tools like Docker, GitHub, and Travis CI. And we also bring in unit testing and different types of linters. So if you join the team, you would be getting a lot of different experiences on how you would actually work in a software team in the real world. Next slide. All our software runs on Ubuntu systems because that's the system that we've chosen to run on the robot. We also use Robot Operating System, ROS, for our robotics networking framework. We use a plethora of languages depending on what task, what level of our stack that we're trying to solve this problem in, and a lot of different open source libraries, vision frameworks, and of course, continuous integration tools. So one challenge with COVID is obviously working remotely since we're not able to be in the same place and work on the robot together. But the software team, it's a little bit easier because the tooling is set up for asynchronous work. And we're trying to add more documentation about our systems on this platform called Bookstack. And we regularly use Slack and Google Meet for our meetings. And of course, like all the tools that were mentioned in the previous slides, they're all available online. So joining the software team is as easy as just joining the Slack channel and just coming to our meetings, and you get tasks to kind of work on by yourself. So our major tasks this year, number one is our Gazebo migration. So we're using Gazebo as our newest simulator, the one that you saw in the slide about simulators. This has upgraded physics engines, and it can detect collisions better. We're also looking to simulate different types of actuators like torpedoes, droppers, and claws. This is something we were not able to do before, and this would improve the testability of our stack even without a pool test. And also, we're looking to improve our mapping systems and our vision stack. So the expectations for a member of the software team is, like obviously school is going to take up a lot of your time, but we're hoping to provide an experience where you can work with a software team and kind of get a precursor of building software for a large-scale project like this. So the expectations kind of follow suit. But at the same time, we're hoping that this can enrich your university experience and prepare you for any such job in the future. That being said, we're also here to have a great time. I don't know if you would be able to break as many computers as James has in this picture, but you never know. So yeah, I'll pass the mic on to our admin team.
Hello, my name is Nigel Woodhouse. I'm in my final year of a master's in computer engineering, and I'm one of the admin co-leads for this year.
Hi, everyone. My name is Nina, and I am the other admin team co-lead on ARVP. and I'm currently in my third year of mechanical engineering. So, the admin team manages all the essential underlying duties to ensure that ARVP runs smoothly as a student group. Whether this means establishing connections with companies in the robotics industry, overseeing competition logistics, or promoting the group and sharing our progress through social media posts, the admin team role is to orchestrate the team's activity and works to get the ARVP name out to the people. This is obviously working because you're here watching us present today. However, the responsibilities that we're tasked with fall into many different categories. Due to this, our team further divides into 4 separate sub-teams, which is the promotions, logistics, event organization, and treasury teams. We'll talk a bit more into detail about the roles that each of the teams have. If you've ever seen news about ARVP, whether it be through social media, newsletters, or even on the ESS website, it's a result of all the effort of our hardworking members on the promotion team. The promotion sub-team manage most of ARVP's advertising and marketing, and are involved with tasks such as designing merchandise, keeping the community updated about our activities. Joining the promotions team is a great opportunity for you to build your networking skills as well. Many of our members have benefited from those experiences. However, it isn't all about tasks like establishing connections or selling merchandise. Much of the admin team's activities reside within the logistics sub-team, where our members are in charge of the organizational side on project management. Key roles in website maintenance, overseeing operations on our internal task board, even writing documentation are quite important. Without the members on the logistics team, many seemingly minute details would eventually make it hard for our team to function as a whole. In order for ARVP to attend events like RoboSub, the logistics team works hard behind the scenes to ensure that every detail and issue has been addressed and accounted for.
Build upon your organizational abilities with the events team. We look to provide our members with a unique and memorable experiences in their educational careers, to provide a break from the hassle of the scholastic burden university provides. We run a mixture of both team promotional activities and other events purely for your enjoyment. Some of the promotional activities that we run involves going to sponsored events and networking, outreach events such as going to high schools to show off our robots, and public pool tests, where we go down to the Kinsman pool and test out a robot in the dive tanks. Not to mention that we organize the logistics behind attending the RoboSub competition in San Diego. But to expand upon these points, we make our activities lighthearted and fun as well. We look for various ways to promote our robot by going on news networks or hold a robot showcase at the Kinsman pool. We organize a Christmas party, camping trips, potluck, and a formal event later in the year to give us a reason to kick back and relax. Of course, all of these events are pandemic pending. In response, we are moving our activities to an online format that includes a Minecraft server, Jackbox games, movie nights, and more. Now, not to give any preference to any sub-team over another, but the treasury team is probably the most important. It serves as the backbone of the group, without whom the rest of the team could not function. The duties include building a network with companies, reaching out to sponsors, applying for grants and donations, and setting up fundraising activities. If you're thinking about pursuing a master's program or PhD, you will likely need to know how to write grants to fund your research project. This is a great opportunity to obtain that necessary experience to build upon those essential skills. In previous years, we relied on crowdfunding activities to support us financially. Last year, we raised $6,400, but a pandemic hit as we launched. In 2017, however, we raised an astounding $18,000. We typically run these campaigns when we are building a new robot, but in hand to promote these campaigns, there are also the logistics of filming the team video, promoting it on social media, and reaching out to companies. So there are various ways to be involved with the finances of our team beyond balancing books. As an aside, and not to make you feel guilty, the admin team tends to be the group that is overlooked when joining one of these engineering clubs. It's nice, it's great to work on those technical skills. Heck, that's why you've come to school in the first place. For any of you who knows anybody in industry or has worked a co-op position before, you'll know that the engineering world is much more than just technical details, math, and equations. Your ability to organize a team, build a company culture, communicate effectively with stakeholders, and lead with confidence will propel you far in your career. The admin team offers these opportunities. Overall, the administration team collaborates with the technical teams to keep ARVP afloat.
Big Alberta proud ARVP.
But why should you join us in the first place? ARVP offers the opportunity for hands-on, albeit socially distanced, learning, expanding upon many of the engineering fundamentals that you only learn about in your classes and never practically use. The experiences provided through the team will develop your competencies and provide that engineering experience employers are always looking for. No experience, not in engineering, doesn't matter. If you're interested, you should join anyways. I hope that our conversation today with our team's leadership has convinced you that we can find a role that's just right for you. Overall, ARVP collaborates closely with each other. We bring forth a host of knowledge and experiences that we want to share with you. Being a part of this team, it is our duty to facilitate the opportunity for students at the University of Alberta to apply and practice both engineering hard and soft skills. Especially in this era of social isolation, the university experience is lost. Meeting new people, the camaraderie, the events in quad, trips to Rat and Dewey's, long Timmy's lines, they're all gone. We offer you our hand so that you may meet new people, make friends, build a study group, learn from others in different academic years and disciplines, and most importantly, develop yourself as an engineer and as an individual. We look forward to working with you soon. Will you accept our invitation?
So if you're interested in joining us and you haven't done so, you can do so by going to our website, arvp.org, and signing up there. You can see our next meeting times up on the slide here. They will all be held remotely through Google Meets.
Thanks for showing up, guys. You can find us at our website, arvp.org. There's a sign up there as well. If you just follow that link and fill out the form, you'll get an invitation to our Slack that you can use, and then we'll onboard you right away. We also have email, Facebook, Instagram, and don't forget to sign up for our newsletter. And now we'll open the floor for any questions. If you have any, just post them into the chat, and we'll answer them.
Yeah, we'll just give it a few minutes before we sign off if any questions come up. Dewey's still open. We want to keep everyone safe. I don't think we can take the whole team there at the same time.
Might want to ask about our Minecraft server.
It is a very fun server.
Well, while we're here and we're waiting for questions to come in, we might as well go through anybody. This is kind of an open question. As what enticed you to join ARVP in the first place? Like why ARVP over, say, another team?
I figured out ARVP existed when I was in high school, actually. I went to the university open house and saw this team, and that really convinced me to come to U of A and to join the club. So I joined in first year, and honestly, it got me through first year. We all know first year engineering is rough, and being on this team really helped me just meet people, get some help from senior members, and actually have something fun to do on top of all the crazy schoolwork you have to do.
I joined in my first year as well. I think it was one of my buddies in Lister told me that, hey, there's this group ARVP and they have an underwater robot. And at the time, I was searching for some groups to do programming with because I wanted the experience of like programming on a team so I could like do something bigger than the kind of small scale projects like you can do by yourself. They're awesome, but like you can do a lot more as a team. So I joined and it's been a fun time, especially like all the complex stuff we get to look at, like computer vision, like control systems. There's a lot of breadth and a lot of learning.
Yeah, I think just something that I can add on to that point for anybody, especially in your early years of undergraduate. I passed through my undergraduate degree without joining any teams or clubs or anything like that. I just focused purely on the scholastic aspect of it. But now that I've come back to university, I've realized that there's a lot more of an experience that you can have when you're focused on a project and working with like-minded individuals. So it definitely adds to that university experience overall, which is something that we all of us here at ARVP, not just the executive team, but other members as well, is looking to promote. And we hope that you join us along that journey.
It looks like we have a question here for electrical. So what specific task is electrical working on and / research these days?
If we could just come up to slide 30. Perfect, thank you. So these are the tasks that we'll be undertaking. The mechanical arm driver circuitry. So that's for the mechanical arm that's being put in. We haven't had an arm in the past. Currently, so that hasn't started yet. We're currently working on an underwater acoustic modem. So we're designing one. It's basically like kind of for inter-robot communication, but we don't have a second robot. So it's kind of just like we're going to prove that we can communicate with other things underwater. And it's a lot of points, but this is a pretty difficult one. No team has been able to do it before, so this will be one that probably most newer members will be under because I'm going to be splitting it up into several subgroups. Yeah, then we're doing some revamps of like PCB and firmware stuff. And assembling the boards that came in last year that we didn't get a chance to work on. And yeah, documentation doesn't really apply to you because you don't really know much about the robot yet. So that's just something for you to know that we are improving documentation for you to be able to join easier. Yeah, I hope that answers it.
Perfect. And we also have another question about if you're able to join more than one sub-team. You're more than welcome to join as many sub-teams as you would like. You can help out wherever you want, you learn and get a broader aspect. So if you're already in Slack, you can just join each sub-team Slack channel, come to the meetings and see what it's all about. If not, again, sign up. And then once you're in the Slack channel, you can join as many sub-teams as you like.
Yeah, like if you just want to show up to the meetings for all the teams, like you can join all the teams at once if you really want to. Like it's all up to you.
Here, I'll pose another question for anybody who would like to answer it. Suppose you're a first year coming into engineering and you're wanting to get involved, but you feel that you don't have the technical knowledge or feel that because you are a first year, you don't know how to contribute. Where's the best place for a first year to start?
I would say
think the best way, I think the best way for a first year to start, just show up to the meetings. All our execs are very familiar on which tasks are more suited for first years. I know when I came in as a first year, I knew nothing about doing mechanical stuff. I didn't know how to use SolidWorks, but we'll teach you everything you need to know and obviously set you up with easier tasks. We're not going to throw you into the deep end right away, I promise.
When I joined
that being
the software team in my first year, I didn't know how to use GitHub or like compile code or like a lot of stuff. Like it really was like an internship from like zero experience, and the team brought me up to speed to where I needed to be.
That being said, it's also really important to get to work on projects that you find personally really interesting. So just pick whatever you think looks cool, and I'm sure you probably won't land wrong.
Like even if you don't feel like you can contribute a lot, like just being around and like monitoring what's happening, like that'll help you get up to speed just by itself, right? Because you'll know what's happening, get that breadth, and figure out the stuff that you might want to learn on your own time later. Like you don't know what you don't know, right?
For those of you who have been on the team before and were able to go to San Diego, what was the experience like in San Diego?
I went the year when it was like when it was pretty crazy, because a lot of people wanted to party. But overall, it's you like pick up a lot because you have to like constantly like problem solve. Because if you know like anything about working with like technology or whatever, everything breaks as soon as you have to present it. So yeah, there was like a lot of fixing things, a lot of troubleshooting. Yeah, I learned like a lot there.
I learned a ton. It was like, aside from the technical stuff, it was just like really fun because we went to the San Diego Zoo, and there's an aircraft carrier there too that has like helicopters and like planes on it. And we went through I think it's the USS Midway. Yeah, that was really fun. But like just watching how the team comes together and organizes, especially when it's like crunch time, like maybe we're trying to push some code and in 20 minutes we have to be on the dock at the transdeck pool to get the drone ready to work. Like it's stressful, but it really helps build team skills.
Here, I'll pose another question out there for whoever would like to answer this one as well. Like, what's the advantage of joining an engineering team in terms of looking at your engineering career, looking beyond? What opportunities can a team like this provide? Anybody like to answer that one?
I actually want to answer that one because I am currently pursuing a career in software, like after school. And just by working in the software team, you just get more comfortable with code. And I'd say that's just understanding how how programming works. Even in your first and second years, like when I was part of the team, like I was kind of on and off with ARVP at the time, but just learning about code and just learning about how to work with code, how to approach problems that are programming problems, really helped me with my career right now. So I hope that answers that question.
Yeah, we can elaborate on that a bit. I see that Randy is watching our stream. He is a previous member of ARVP. He mentions that it actually enriches your class experience, though, because you can tie the practical together with the theoretical that you learn in class, which I think is a very nice way to tie things together. Yeah, because especially if you think about it with all the other people that are in engineering with you. Oh, sorry, your current member. My bad. Sorry. If you think about all the people that are in engineering with you and just going through the classes, especially when you're going out to interviews, it's how do you set yourself apart from all the other individuals that you're with. And so doing these extra activities, engineering classes, engineering clubs and stuff like that, it will set you apart from the rest of the students. So I definitely recommend. It doesn't have to be just ARVP. It could be any other engineering team, but we're a little biased on this one. So we hope you join.
I'll put in my 2 cents as well, I guess. When I first joined ARVP, I was in second year, and I was kind of not really sure what I wanted out of engineering in general. Being on ARVP is pretty helpful because we have so many different teams, and you can develop a lot of skills depending on what team you join. And if you're not really sure about like what you're interested in, even like in general in engineering, I feel like joining a student group is pretty helpful in that way. You can kind of experience and see what you like or what you don't like. And it can definitely help you influence your decision for your academic career in the future.
In terms of programming, like it really helped me apply the theory and helped me like retain the knowledge in my coursework. So I'd say it was like it didn't really take away from the time so much of like studying, even just because it helps me learn the material even better.
There, I think with that, this might be a good place to wrap things up overall. So,
Yeah, thanks everyone for coming out to our annual general meeting. Obviously, the format was a little different this year. Hopefully, you still enjoyed it still, and we'll see you on the team, hopefully. Thanks, everyone.
Thanks for coming.